This is our pump-through barrier for synthetic ester fluid, and how this works is we have a vessel over at the discharge end of our polishing filter, and that is going to be turned on, and it's going to pump the water into our pump-through barrier. The water is going to filter through our canister on the inside. It drains through to the bottom and drains into the polishing filter, which there is another pump inside the polishing filter that will pump it through, and it discharges at the end. So how we're going to start is Dave is going to plug in the pump, and we're going to start the flow of water. Okay, so now we have straight water going through. The flow-through rate of the pump-through barrier for synthetic ester is roughly 12 gallons per minute. The water is coming in. If on the inside of the housing is an overflow valve, and that will come into play primarily when we start pumping the oil into the pump-through barrier. So the water is coming in. Has it started to drain out the other end? Okay, now you should start to see the water discharging. So now we've established the flow rate initially, and so the next thing is we're going to pour our oil and water into our vessel that's going to actually be pumped into the pump-through barrier. So we're going to get ready, and we'll pour the 5-gallon buckets of oil and water into the vessel behind me. Now we have Kevin in the black shirt, Dave in the blue shirt. They're pouring the Midel 7131 and water into the holding vessel at the same time. They're going to be pouring a total of 30 gallons into the container. Here's the second round. And once the oil and water is in, we'll be turning on the pump and start pumping the oil and water emulsion into our pump-through barrier. What a soup. What a soup of oil that is. Okay, so now they're moving the buckets out, and they're getting ready, and they're going to turn on the pump, and we are going to start pumping the oil-water mixture into the pump-through barrier. The oil-water emulsion is now being pumped into the pump-through barrier. I'm controlling it with the valve. I shut off the initial water, and you can see the oil water looks almost like milk. Now it's approaching the overflow valve. Once it hits the overflow valve, it's returned to the vessel. So now you can see the emulsion is actually being sent back through the hose. It's going through the hose. So if this was a real spill, what would be happening is the oil has been stopped and the oil is being returned into the oil containment area. At the same time as we're doing this, Dave is taking samples of the water that's discharging to make sure that we're below a 5 part per million oil and grease level. And in all the tests that we have done so far, that's been very successful. So now we're regulating it, so the oil and water is going in. It's starting to drain much less because now the oil is impacted into the media in the canister, and we've got a steady stream of oil and water going back into the unit. Well, this is the conclusion to the pump-through barrier synthetic ester test. I'm going to take the cover off. And you can see the milky solution is still being pumped into the pump-through barrier, and the oil is being returned into the oil containment vessel. This has been going on now for 2 hours and 5 minutes. Utility companies require that an oil containment holds back oil for 2 hours. And especially in the pump-through barrier, this is the most difficult type of oil to hold back because it's a total emulsion. And we're pumping that oil continuously for 2 hours. So this has been pumping. It discharges through the bottom, then it pumps up into the polishing filter, and then it discharges from the polishing filter into the vessel below that Dave, our chemist, has been taking samples every time water starts coming out. And so we will send those samples off to the lab. What I'm going to do is I'm going to now shut the water and oil solution from going into the pump-through barrier. So that's off. Now the oil emulsion is going to go through the 2-inch valve back to the oil containment vessel. And it's going to sink down. And then tomorrow we're going to check this out again, and the oil level will have gone down substantially, because as the emulsion breaks, the water continues to go through our media canister, which is another amazing thing, because the media canister has already stopped the Midel oil from going through, but will still allow water to go through. Very slowly, but it does. And so this is going to continue to go down, and tomorrow we'll relook at this and we'll show you the results tomorrow. But as of now, this was a 100% success. Once again, Solidification Products has proven that when we're asked to meet a challenge, that we're there to do it. So thank you very much, and we'll talk to you tomorrow. Well, it's been 15 hours now since we shut off the oil and water emulsion that was being pumped into the pump-through barrier. And you can see the color of the oil. It's sort of still a milky, mustardy color. And the oil level, since we stopped yesterday, has only gone down about 1 inch. So the pump-through barrier has solidified and held back all of the Midel 7131, and another success. What we're going to do at this point is Dave is going to turn the pump on and get the final amount of water that would have drained overnight. And we'll take one last sample. So this water would have been what had been leaked through our media over the last 15 hours. Since the critical time for the oil system to work is only 2 hours, we far exceeded that. This would be the max amount of water, as you can see, that would escape anyway. And for the most part, it's pretty crystal clear. So that's the conclusion of our pump-through barrier with our polishing unit for synthetic ester, specifically Midel 7131. Thank you.